Good morning, everyone, or good afternoon, depending on where you're joining us from. My name is Adrian, and I want to welcome you to our monthly meetup. Today, we're going to be discussing multi-tenant app catalogs, multi-cluster apps, and global DNS. And I just realized I'm not sharing my screen. Just a moment. And now I'm sharing the wrong screen. There we go. All right, so once again, welcome. This mouthful of a subject is what we'll be discussing today. And I am not Shannon Williams. These meetups are normally hosted by Shannon, but today you have me. My name is Adrian Goins. I am a senior solutions architect here at Rancher. And I am joined today by Rajashri Mandogani and Prachi Damle, two of our software engineers. You guys want to say hello?
Hi everyone. Hey everyone.
Hey, there we go. So, first things first. This is not a webinar. This is a meetup. And so that means that we are going to demo. We're going to talk about things. We're going to answer questions. We're going to make this more of a back and forth social engagement where you guys get to interact with us. It probably means that we're not going to finish on time. I think we have 2 hours blocked out for this, but if you look at the history of meetups, they tend to run long or short, if we run out of stuff to talk about. But we would like for you to ask questions. I'll be answering questions during the demonstration portion, and then if there are questions for the presenters, we can field those at the end. So we will answer all of your questions. We will endeavor to stay until the end of the last question. But the ones that we will be taking first are going to be questions related to the demonstrations and the subject matter that we're presenting. So if you ask a question and we don't answer it right away, if we have time at the end, we may circle back and address those. So if you have general Docker, Kubernetes, Rancher questions, we'll still try to get those answered. We do live demos in our meetups. So that means that things might not work. This is all live. It's not pre-recorded. The things do break, and if they do, we'll figure it out. So we're all in this together. This meetup is being recorded. I'm actually going to check right now and make sure that that's the case. Yep, we are recording this. You will get so we will upload it to our YouTube channel generally within a day or two. See the link down there at the bottom. And so you'll be able to watch it if you have to leave early or if you want to come back and see any of the demonstrations or how we answer some questions, it'll be available for you. Please tweet about this. Use the hashtag RancherMeetup, put a photo of yourself out there, tell us what you think. As you see, we love this. We will take your photos and we will add these to future slides so that we can share them with other people. We also have a Slack channel. If you go to slack.rancher.io, you can join our Rancher user Slack and then join the channel online meetup. And all of you can participate there and talk and see what's going on. And I'm going to mute Slack so it stops bothering me. There we go. So tweet, chat, join the meetup, join the Slack channel, and let's get started. So as I said, my name is Adrian Goins. I'm going to give you a couple of slides that introduce you to Rancher, just in case you're new to Rancher, new to Kubernetes, just to give you an idea of where we are and what we have to offer for you. And then we're going to hand it off to Rajashri, who's going to demonstrate one of the features coming out, one of the features already available in Rancher 2.2 preview releases. Rancher 2.2 will be released to GA at the end of March, but you can already bring these down, test them out, see how they work in a development environment, and provide feedback. Because we are an open source product, we like to release features out to the public so you guys can start to kick the tires and let us know what works, what doesn't, so we can iterate appropriately. After Rajashri shows multi-tenant app catalogs, we're going to hand it off to Prachi, who's going to introduce you to multi-cluster applications and global DNS, which is an amazing benefit that's out in Rancher 2.2 right now. We're going to have some demos here. There's actually, Rajashri has a short demo, and then we're going to do some hands-on stuff with Prachi as well. And then I'll wrap it up. Rancher, if you're not aware of us, is a very popular platform for deploying and managing Kubernetes clusters running anywhere. So Kubernetes it's almost a commodity at this point. It's taken the market by storm, and you can get your Kubernetes from really anywhere. You can get it from Amazon, you can get it from Google, you can build it yourself, you can run it on cloud instances. Kubernetes is all over. Rancher integrates with Kubernetes to deploy it and manage it and give you a set of frameworks to connect to existing systems like authentication, role-based access control, CI/CD systems, to take Kubernetes and make it something that you can use in the enterprise without significant difficulty. Rancher is totally open source. We pay the bills by providing support services for customers who wish to have the product supported when they're running it in their production environment. But everything that you're going to see is available for you to use. There's no community edition. There's no enterprise version. It's all out there. Every single product that we have, whether it's Rancher itself, Rancher Kubernetes Engine, Rancher OS, or some other stuff that you guys are going to see coming out in the next few months, is all 100% free and open source and available for you to use. Rancher provides a nice integration between these two often competing groups. You have Central IT, who's focused on cluster management, security, access control, maintaining the integrity of the clusters themselves. And then you have DevOps, who are focused on pushing applications out, making applications available, velocity, and things related to the delivery of services from within Kubernetes. Rancher provides a way for these two teams to work together. So the needs of IT and the needs of developers. And we do this by bringing tools like multi-cluster management, by integrating authentication at the global level. So you can plug this into backend authentication providers, create policies that then are applied to all of your clusters under management, integrating with CI/CD systems, monitoring, logging, alerting. All of these tools are built into the product so that once you deploy Rancher, you can get right to work using the Kubernetes clusters that it manages and spend more time utilizing those things than you have to spend on actually managing them. Shannon, who normally does these meetups, likes to use the metaphor that if Kubernetes is an engine, Rancher is a car. Rancher takes that engine and builds things around it to make it possible for you to go places and to do so with speed and fashion. If you're interested in learning more about Rancher or Kubernetes, we run a weekly online training, which is an introduction to Kubernetes and Rancher. You can go to our website, rancher.com, and under the Learn tab, fall down to find links to join that. So with that, let's dive right into today's subjects. I will hand control of this over to Rajashri, and we'll get started.
Hey, Adrian.
You should have control.
Yeah, can you see my screen?
Yep, we see your screen. Take it away.
Sure, thanks. So, yeah, once again, welcome everyone to the online meetup. And like Adrian said, I'll be going over the new 2.2 feature, which lets users add catalogs at the cluster and project level. So before that, I just want to go through all the benefits that Rancher Catalog offers. In Rancher, you can add application catalogs, which are basically repositories containing Helm charts or Rancher charts. And once added, users can install case apps from these charts that come from the catalogs. So The Rancher catalog can contain Helm charts. And for those of you who aren't familiar with Helm, Helm is a package manager for K8's apps. I've read this analogy somewhere online, which I really like, that Helm is for Kubernetes, what Homebrew is for Mac, or how apt-get is on Ubuntu. Helm gives an efficient way of installing apps in your Kubernetes clusters. There are many apps such as Nginx or MySQL, which are frequently needed by other applications. And with Helm, you can just install these apps easily with a single command. Along with that, Helm also has a way of keeping a track of different releases or revisions of your app that have been installed. So you can upgrade to a newer version or roll back to an older one. And also, if you want to share any of the applications that you are developing with others, like say your colleagues, you can package it through Helm and make it available. And any such packaged app, like Helm package is called a Helm chart. And a chart repository is a collection of such charts. So you can simply install any of these existing packaged apps or publish your own. This is the chart layout. In each Helm chart, there has to be a chart YAML file, which is like the metadata. It consists of the name, version, author, and so on. And then there's a folder for templates, which contains a list of YAML files defining your K8's resources. These YAML files are also called manifests. Then there's a charts folder, which provides you with an option where you can list all of your dependencies, or there's also a requirements YAML file where you can directly just give a list of whatever things your charts need to have installed beforehand. So I think Helm is a really amazing tool because as a developer, if I say I require MySQL app, I don't have to create my own manifest for all the K8's resources. And nor do I have to copy paste some existing manifests and pass them to the kubectl create command. I can just install it with a single command. Also, the way it handles dependencies is pretty great. Like I showed you earlier, you just have to specify them in say your requirements.yaml, and then again running a single command will install all those dependencies as well. Another important feature is the version control, like I said earlier, and it's really great because it keeps a track of all the versions that you have installed so far. So there are many great tutorials and docs on managing your K8's apps on clusters with Helm. And like the Helm website itself has great tutorials on how you can set up it on your cluster. But when it comes to managing your apps on a multiple cluster setup, there are many things you'll have to take care of. Since Rancher has to manage multiple user clusters, we handle Helm and Tiller a little differently 2.1 onwards. So we maintain a fork of community Helm, and we built our own Helm and Tiller binaries and package them into the Rancher server. Now, they don't differ much from the upstream binaries, but Rancher Helm provides a lot of advantages for managing your apps in a multiple cluster setup. So let's say you're managing multiple clusters. Helm CLI uses, or rather requires, the kubeconfig to point to the right cluster for app installation, meaning you will have to manage context switching between these clusters each time you have to install an app. Now, this might seem like a lot of work, especially when actual app installation can be done with a single command. Also, you'll have to secure your Tiller installation. So what is Tiller? Tiller is the server-side component of Helm, and it is usually started as a pod in the K8's cluster. Now, this Tiller pod is the actual component that will actually install your app and keep a track of all the releases. So one of the main ways of securing Tiller is through creating a service account for this Tiller pod. And it is very necessary to have proper permissions for Tiller because it can launch, update, or delete apps. So you don't want an insecure installation where any user can delete an app that other users in the cluster could be using. And so, since Rancher does the job of managing multiple clusters for you, It also takes care of all these things related to launching the app in all clusters, or RBAC for Tiller. So RBAC for Tiller is done via user impersonation. When you start your Rancher server, either local auth is enabled, and most commonly, some external auth will also be enabled later on. So only users that the admin grants permission to can access the Rancher server. Once a user logs in and tries to launch an app, we create a token for this user, and then we maintain it for any future app installation requests. Then we get the context of the current cluster. So this way, we know from whom the request is coming and for which cluster the request is. The token is then set as an impersonation header in the API server request. Now, since Rancher is managing multiple clusters, we can get the context of the current cluster, and you don't have to take care of that either. Also, instead of starting Tiller as a pod in each user cluster, we start Tiller as a process for app installation. This also makes app installation in parallel possible. Now, this is kind of like a high-level diagram showing how we manage the Helm installation. So this is the Rancher server management plane that you can see in the blue box. And below are some user clusters, clusters A, B, and C. And for each of these user clusters, we start a Helm controller. So when a request to launch an app comes to any of these Helm controllers, it starts the Tiller process in that cluster. And again, the impersonation header, like the RBAC using impersonation header that I spoke about, is used. Another advantages of integrating Helm with the Rancher catalog feature is that Rancher fetches and saves all the data related to your charts in some custom resource definitions such as templates, template versions, and template contents. So this way, each request to install a chart doesn't have to fetch it from the chart repository, and it can be much faster by reading the stored chart contents. We periodically, at some interval, keep checking for updates to these charts, and since we fetch all the template versions, you can easily pick from a list of all template versions. So, like this way, we also maintain a history of all the templates in your charts. And Rancher users in general have great things to say about our user interface. So before you launch any of the catalog apps, the UI creates a namespace dedicated for all workloads from that app. And it also shows you, once you launch an app, if a higher version of that app is available. So like if it is available, then you can just directly click upgrade on that app. So on the very first slide, I had said that the Rancher catalog can contain Helm charts and Rancher charts. So we saw what a Helm chart is. It is a packaged Helm app. And let's take a look at what a Rancher chart is. So Rancher chart is very much like a Helm chart, but with these two additional files. The first one being app readme.md. So it just displays some extra information about your app. It's basically like a descriptive text for the chart in the Rancher UI. And the second one is questions.yaml. So like while you're installing any Helm application, your manifest in the templates folder that I showed earlier could contain some variables, such as which tag of an image to use and so on. And while installing the app, you can pass values for these variables by setting answers. And these answers are provided in the form of key value pairs. So let's say if you have to set multiple answers, then you will have to keep on passing multiple key value pairs. And this can be tedious, but instead of that, we have this questions.yaml file, which presents you with a form where you can just fill out all the answers. So as opposed to just keep on passing these key value pairs where you have to make sure that you also are passing the right key You can just fill out the answers to these keys. And now finally, the Rancher catalog. So like I said, Rancher catalog is basically a repository containing Rancher charts or Helm charts. You can add any of the Helm chart repositories you might already be using, or if you have a GitHub repository containing your own charts, then you can add that as well. You can also create different catalogs for different branches of these repositories. So far, like before 2.2, users, like admins actually could create these Rancher catalogs at the global level, and all the charts from these catalogs were accessible by everyone. So basically, users in all clusters and all projects had equal access to the charts or templates from this global catalog. Now, the issue with this was you could have a setup where one cluster is dedicated for a particular team. Like let's say a cluster is dedicated for the dev team, one cluster is dedicated for QA. So in this case, you would like to have different charts available for these clusters. Now, there are also some companies which like to dedicate a cluster to a certain customer. So in that case, isolation between these catalogs that are made available to these clusters becomes even more necessary because a cluster could be dedicated to one customer. And the same kind of need also came up with projects. Like we were also needed to ensure isolation between catalogs for different projects. And that's the reason we have added the catalog feature at the cluster and project level as well. So let's say a cluster owner adds a catalog for their own cluster. Uh, like members of other clusters won't be able to see it. And that way you just have dedicated charts for your cluster. And similarly, you can also add catalogs at the project level and isolate them from all other projects in that same cluster or different clusters as well. So this is how it will work. Like in the Rancher management plane, you can of course you can still keep on adding your global catalogs, but then yeah. So first of all, an admin can create the global catalogs still, and an admin can create cluster level or project level catalogs in all clusters and projects. And let's say you are just logged in as a user, you can continue to use charts like templates or template versions from the global catalogs. Now, if you become the owner of a cluster catalog, then you can create, if you become the owner of, say, this cluster A, then you can create a cluster catalog in it. And if you become a member of it, then you can use the charts from this cluster catalog. Since you are not yet a member of cluster B, you can't do anything with the charts that have been created in, that have been created for the catalogs of cluster B. And similarly, now if you become a project owner by creating a project of your own, then you can also add a catalog at the project level for that project. And since you haven't been made a part of the project PA2, you won't be able to use any of the charts that belong to the project catalog in that project. And this is just a use case showing how it will be if you are a part of some other cluster. You don't have access to any catalogs that were created for the cluster A. Now I just want to show how you can add them, like add the catalogs at different levels. So first of all, till 2.2, I think you could see this catalog stack at the global level. Now 2.2 onwards, you can also go to any of the clusters you have created, and you will see this catalog stack being available there as well. So you can just click on it, and you can add any catalog you want. Let's say cluster A. Now you can give the catalog URL, like which contains all the charts that you want to add. And you can select any branch that you want to use from this GitHub repository. Okay, so Over here, you can see that the state of your catalog is active, meaning all the templates, template versions, and so on have been created for this catalog. And similarly, you can go to any of the projects that you have created or you own. Over there, if you click on catalog apps, earlier you could only see this launch button, but now next to it, you can also see manage catalogs. So once you click on it, you can go ahead and add a catalog for the scope of this project as well. And similarly, you can just add some catalog here. Again, this should show you if your catalog has been added successfully or not. Now let's say it's time to launch an app. So you can go to this, well, the same page which you have been using to launch apps. And from here, in this dropdown, you'll get a list of all the catalogs that are available to you. So you can just filter out a template like by selecting the catalog. And let's try launching one of the catalogs. So yeah, you can just launch it then. And again, only users who have been explicitly added to the members list of this cluster will be able to launch an app from this cluster catalog. And same goes for the project catalogs as well. So yeah, so that's all that I had to share about this multi-tenant catalog visibility. And now I'll just pass on the control to Prachi.
Oh, actually, let's pause there for a second. There's a couple of questions if we can just take a minute and answer them. First of all, fantastic presentation. This is something that I know our user base has been asking for a long time, and it's great for companies that are doing Kubernetes as a service, for example, and want to make sure that they're not showing everything to everybody as far as the catalogs are concerned. We have a question. It's actually come up a couple of times. People are asking if the catalog repos will support authentication if the repo is not public.
Yeah, sure. It will support authentication. I actually forgot to mention it. Can you see my screen again?
Yes, I can.
So while adding a catalog, this is actually another new feature in 2.2. So while adding this catalog, you can click on this use private catalog button and then provide your username password. So yeah, you can add those catalogs which also have authentication.
Oh, that's great. And then if the images themselves that are referenced within the Helm chart are coming from a private repo, or a private registry, do those registries have to be added directly within the registry resource before we can pull from
Uh,
them?
yeah, I believe so. Yeah, if the images that your app are using, if they are coming from a private registry, I think yeah, I'm not sure of it, but I think they need to be
Yeah, so it'd be under the project and then resources.
oh, right. Yeah, I think needs to be they need to be added here.
Yeah. Okay. So any registry that's added there could be used for any deployment, whether it's a Helm chart or a standard deployment, right?
Right, I think so.
Okay. We have another question that snuck in under the wire here. Interesting. What about SSL for the catalog? So I'm not sure about this question, but Guy is asking, what about SSL for the catalog? He says that the SSL root CA for Let's Encrypt is not currently included in Rancher. It has to be manually added to the container. Do you know anything about that?
No, I'm not I'm sorry, I don't know anything about that.
Okay. So, Guy, as far as the SSL root CA for Let's Encrypt not being currently included in Rancher, I'm not familiar with that either. We use Let's Encrypt certs for pretty much everything. So if you have more information on that, or if that's an issue, then certainly please open an issue on GitHub, and we'd be happy to take a look. As far as SSL for the catalog itself, Interesting. So perhaps you're saying that if the catalog is coming from an HTTPS URL that's backed by Let's Encrypt, it doesn't work. Also, not familiar with that. So if you can duplicate that, please open a GitHub issue and we'll take a look. Let's see. Satyan is asking if this supports a private Quay registry or Artifactory Docker registry. And I can answer that yes, it does. If you can go back to the registries tab and show adding a registry.
Yeah.
So Docker Hub, Quay, Artifactory, Harbor, Nexus, private registry, GitLab, whatever. We can talk to all of them. Let's see if there's any other questions here. Okay, so those are all of the questions for Rajashree. So let's switch over to Prachi.
Hey Adrian or Rajesh, can you make me the presenter?
Oh, yeah, sorry. I was thinking you could just become the presenter yourself, but you can't. 1 second. All right, you should be the presenter now.
All right. Can you see my screen?
Yes.
Checking.
Yep, we can see your screen.
All right. So, moving on, after the multi-tenant catalog, we have the walkthrough with multi-cluster app and global DNS that are coming in Rancher 2.2. So, quickly I'll go over the agenda that I will be presenting on. So, I'll be talking about the feature highlights for these two features, multi-cluster app and global DNS. Then we'll cover or highlight some use cases that these two features can help in solving. Moving on, we will go to the user workflow, what and how the user can use these features, what the users have to do with Rancher 2.2 UI or API to make use of these features. Then we'll dive into a little bit of technical insight, how we are implementing these two features with Rancher, and then move on to demoing these two features on the UI, and then we can answer any questions anybody has. So the feature highlights, as we all know, Rancher 2.x is a platform to manage all of your Kubernetes clusters. You can add multiple Kubernetes clusters and manage them from the central Rancher 2x platform. We also provide centralized RBAC and monitoring of these Kubernetes clusters. Users can deploy their workloads, manage their workloads under each cluster individually. But however, at this point of time, users cannot deploy the workloads onto multiple clusters with Rancher 2x until now. And another piece that has been missing in 2.x is there's no external DNS programming available. So if the workloads want to program a particular DNS server and want to have a host name for their workloads, then there's no external DNS programming available. We right now support the xip.io out of the box. So with 2.2, what Rancher brings is multi-cluster app and global DNS, these two features. With these catalog applications, they can be deployed and managed to multiple target clusters in one go from the global level. And with global DNS, what we are adding is the ability to program an external DNS to route the application traffic to various endpoints in various clusters. So to explain this further, here's a graphical representation of these two features. So we have Rancher user. As Rajeshri mentioned, the Rancher catalog provides a catalog of Helm charts or custom charts added, from which user can select an chart to deploy an app from the catalog. So with multi-cluster app, the workflow will be similar, where user will be able to select an app from the catalog, and then currently, when user selects an app from the catalog, they can deploy it to the cluster under which they are currently situated in. But with multi-cluster app, the workflow will be like user selects an app from the catalog, and using multi-cluster app, they can provide various clusters, multiple clusters as targets for this application. And Rancher will deploy this app Rancher controllers will deploy this app into multiple Kubernetes clusters at the same time. So user is basically trying to deploy this app sitting at a global level outside of all the clusters and picking the target clusters for the same application under which Rancher will go and deploy this application onto. The external DNS part of it is the global DNS controllers that are running in Rancher basically facilitate programming an external DNS provider like Route 53 or Cloudflare um, with the IP addresses from these various target Kubernetes clusters. So if your application is running onto multiple clusters, the external DNS program controllers will be picking up IP addresses from all these target clusters and programming the external DNS provider like Route 53 against these IP addresses with the FQDN of your choice. So moving on to details of these highlights is, so what the multi-cluster apps again is doing is providing a single global interface to deploy the same application to multiple Kubernetes clusters. So just as user can select an application from the Rancher catalog within a cluster and deploy it to that cluster, user can choose an application now, and in addition to that, can provide target clusters and projects, and they can add multiple of these for app scheduling. And further, they can also customize configuration of the application per target cluster or project. Kubernetes provider agnostic is another highlight of multi-cluster app, where the app can be deployed to Kubernetes clusters no matter how the clusters are provisioned. So it does not depend on clusters provided by a particular cloud provider. This actually helps in avoiding cloud provider lock-in. Multi-cluster app uses Helm support internally. So all the cool features of Helm, deployment, upgrading, as well as versioning, all that is available for managing the multi-cluster application. External global DNS feature, what it helps is it's resolving to endpoints from different clusters. So with this, users can achieve high availability for the applications. It's one step closer to achieving high availability for the applications. So if your application is spanning multiple clusters and one of the cluster goes down for some reason, your application, the same application, a copy of that application running in another cluster can still serve the user requests. It can also be useful to achieve low latency based on DNS resolution. So certain DNS providers can help in achieving low latency. So I've already touched upon certain use cases that these two features can help solve. So going over again, so multi-cluster app and global DNS can help in if your applications need high availability. So if your applications are spanning across multiple clusters, spanning multiple geographical regions, multi-cluster app can ensure that the same deployment exists in all these clusters, and it can be used in spreading the user load across the clusters. Another use case is the routine IT operations. IT admins need to push same applications to various clusters. For example, in order to manage the clusters, for monitoring the cluster, for managing security of the clusters, applications like Twistlock and all that, the admins need to push copies of these applications to multiple clusters they are managing. And it is pretty tedious and time consuming, as well as can be an error prone operation. So multi-cluster app feature will help in these cases. Now, cases where users or enterprise users want to avoid cloud provider lock-in, multi-cluster app will help in there, where any particular cloud provider dependency is not present. So users can choose clusters from any cloud provider and keep copies of the same application running on multiple Kubernetes clusters. Another area that this aims in solving is the edge computing cases. So where users can be served by Kubernetes clusters which are closer to their location. So this can be solved using multi-cluster app, where the application is running across various clusters and those which are closer to the user's location can serve the user traffic. Okay, so moving on, the user workflow for multi-cluster app. How can they use multi-cluster app feature? Users can use either the Rancher catalog, which is available, or they can add their own custom Helm catalog for selecting the application to be launched via multi-cluster app. They select an app from the catalog, provide target clusters, and within each cluster they have to select target projects. Projects is a Rancher concept in order to deploy these applications. Rancher will deploy the same app onto multiple clusters that have been specified by the user. Now, this workflow is at the global level outside of all the clusters. So only templates which are available from global level catalog can be used for now. Users can provide answers per cluster and per project to configure the application. So if users want to deploy a particular application to multiple clusters but want to configure, say, username password differently for different clusters, they can be that can be done using multi-cluster app answer override feature. Users can upgrade, rollback, delete the multi-cluster app, which will apply the action to the apps deployed in each target cluster. So from the single interface, users can manage the multi-cluster app and apply all these actions to the applications running in various clusters. Now, the global DNS, to use global DNS, user should add an ingress for the application and use the annotation rancher.io globaldns.hostname and provide the DNS FQDN of their choice that they want to program on the external DNS. Rancher will pick up this ingress and facilitate the external DNS programming. Multi-cluster app, so input fields, it takes in the template version, which is the Helm chart template version. It takes in targets, user selects the project from different clusters, and these are the targets of the multi-cluster app. Another input for multi-cluster app is members. Multi-cluster app can be shared with different users, and users can be assigned peculiar roles, owner, member, or read-only. And another input field is answer overrides. So overrides for some answers at the scope of particular cluster or project can also be done. And roles is another input for multi-cluster app. Little bit of technical insight of multi-cluster app of how we are implementing this. So a catalog app is a Rancher custom resource, and Rancher's Helm controllers listen for app creation and they pick up this app and deploy the workloads in the app onto the cluster. So this feature is already existing, and Rajesh already went over it in detail. When we launch an app in Rancher, an app custom resource is created and picked up by the Helm lifecycle. So multi-cluster app makes use of this. So what we do with multi-cluster app is there's a Rancher controller running in the management plane. Whenever user creates a multi-cluster app and selects the target projects, what the controller is doing is it creates the Rancher app custom resource for every target cluster and project. It creates namespaces in the target projects, and the Helm controller will then pick up these applications from the target cluster and deploy the workloads necessary. Now this operation is done as by a service account. So we create a service account for multi-cluster app and assign some roles to this service account and permissions in order to go to the individual target projects and deploy this application. So multi-cluster app also has an RBAC available. It can be shared via members field. The multi-cluster app creator can add users as members and provide assign roles to the users as owner, member, or read-only. So the owner role lets the users to basically configure the app, add target projects to the app, configure role for the app. The member role basically lets the users in order to add more bring in their own projects or provide the answer overrides for those projects, and read-only roles let the users to just view and monitor the app. The Rancher controller manages creating of these roles and role bindings in the Kubernetes layer. The global DNS feature workflow, user has to deploy basically two entries. One is the global DNS provider and another is the global DNS recorder, the global DNS entry itself. So the global DNS provider on the Rancher, when user deploys that, what happens internally is the provider of the choice, user selects whether he wants to deploy a Route 53 or Cloudflare, and that provider Rancher deploys from the Kubernetes incubator external DNS repo. So currently Route 53 and Cloudflare are enabled in Rancher 2.2. Then the global DNS entry is another record that user needs to create via Rancher UI or API. Here, the Rancher programs or provides the FQDN of their choice and also provides what is the target multi-cluster app that this global DNS entry will be targeting. Or they can also, instead of the multi-cluster app, specify the target clusters or projects that this global DNS entry will be programming for. So when any ingress running in user clusters use an annotation, and the annotation's value is the FQDN of the user's choice, which is specified already in the global DNS entry, then those ingress IP addresses will be picked up by Rancher and they will be programmed onto the external DNS against that FQDN. After the initial programming, Rancher controller will keep on monitoring the state of these ingresses, will consolidate the endpoints from all the clusters to be programmed under this FQDN, and if the ingress goes down or if another host is added to the Kubernetes cluster and an additional ingress IP address is available, in all these cases, the external DNS IP addresses or the endpoints of that FQDN are updated by the Rancher's global DNS provider. So a little bit of technical dive for the global DNS side. User, as we saw, has to create global DNS provider on Rancher. When the provider is created, there is a controller on Rancher side that deploys the same provider from Kubernetes incubator external DNS project as a Kubernetes deployment. Then the provider deployment from the Kubernetes repo is going to look for any ingresses in the management cluster of Rancher. So if any ingress with the host name or FQDN is programmed, the external DNS provider picks that up and programs its IP addresses onto the actual third-party DNS provider. User, when he creates a global DNS entry on the Rancher UI or API and provides an FQDN and targets the multi-cluster app or project, what happens internally is we have a user cluster global DNS controller running. It scans all the ingresses within each user cluster, and if there is an ingress matching this FQDN of the global DNS, we pick up endpoint of that ingresses and record it on the global DNS entry. Then if any ingress create, update, delete event happens, then there's another controller which is reconciling all these events and updating the global DNS endpoints with those ingress IP addresses. At management layer, the global DNS controller is basically looking at the endpoints that are recorded on the global DNS entry and creating a dummy ingress in the management layer with the IP addresses from this endpoint. What happens is because the dummy ingress gets created in the management layer, the global DNS provider, which is we just created at step 1, it picks up that ingress endpoints and programs the external DNS provider with those IP addresses. So to explain this graphically, basically the user applications are running in user clusters, target clusters, and those applications are having, the user workloads are having ingresses which use a DNS label. Rancher controllers are going to pick up these ingresses. If they match the FQDN of a particular global DNS entry that user has created, then those ingress IP addresses are picked up and placed on to a dummy ingress in the management layer of Rancher by a global DNS controller. What this makes happen is the Kubernetes ingress or the SQDN and cluster endpoints get picked up from this dummy ingress by the Kubernetes external DNS deployment that the user has launched, and it picks up these IP addresses and programs it on the third-party external DNS. So with this, I'll move on to actually showcasing these two features. So here I have a Rancher setup with multiple clusters added. So at the global level, there are two tabs, multi-cluster apps and global DNS, that are coming in Rancher 2.2. So on the multi-cluster app, user can, first of all, there are two options, manage catalogs and launch. Where manage catalogs, user is taken to the catalog section where user can add their own catalog or enable the already available Rancher catalogs. Once the catalogs are set in place, users can launch an application from multi-cluster app tab from one of these catalogs. So I'll launch the Grafana app from my custom catalog that I have added. Provide a name and other configuration options of that catalog app. Then this is the feature of multi-cluster app, where along with providing configuration of the application, you provide target clusters or target projects where this application is going to be deployed. So I can select multiple of these target projects at one time. So I can deploy my app to project 1, which is in cluster 1, and project 3, which is in another cluster, cluster 3. Then you can select the upgrade strategy, rolling update, or upgrade all the apps simultaneously. With rolling update, users can specify batch size where apps from particular for that batch will be upgraded first, and then Rancher controller will wait for the specified interval and take the next batch from the multi-cluster app to be upgraded. Then all these are configuration parameters of that particular catalog Helm chart that you have selected. You can add members, other users, you can select and add them and provide roles, and you can share this multi-cluster app that you are creating. You can add roles that are required to view this application. Other section is the answer overrides. So as I'm selecting multiple target clusters and projects here, I may want to configure this app differently for all these targets. So in answer override section, you can select a particular target. Test project 1 is one of my target, and you can select a question from your configuration parameter and answer it differently for that scope. Once you launch this multi-cluster app, Rancher controller is going to create the catalog app into all your target projects, which can be under same or different Kubernetes clusters. And these apps are going to be selected by the Helm controller lifecycle and will be deployed on these target projects. So once your multi-cluster app turns to active state, you can drill down to each target project and you can see that the catalog app is deployed in that cluster and workloads are created which were specified by that application. Going back to the global level, I can also drill down to another target project that I had selected, which is in a different Kubernetes cluster, and see the apps being created there. So this is how multi-cluster app can be configured and launched for various clusters. The other options available for multi-cluster app is you can clone the app, you can upgrade the app, you can roll back to a previous version of the app. So I'll show the upgrade feature, and along with the upgrade, I'll demonstrate the global DNS part of Rancher 2.2. So I'll upgrade my multi-cluster app, and suppose I want to program the external DNS for my application. Now this is a chart from my custom catalog. What I needed to do is, in one of the ingress of my app, I have to provide an ingress annotation and program and specify an FQDN that I need to program on external DNS. So this custom chart is already modified to include the ingress annotation. So here I can specify a host name I want to use. So this is my root domain of my choice. And suppose I want to program an FQDN for this application on my root domain. This is a domain on Route 53. I'm upgrading my existing multi-cluster app and putting this annotation on the ingress of that multi-cluster app. After that, under Global DNS tab, I go and I have to create an DNS provider. I have already created a Route 53 provider. You can select Cloudflare. There's already support being added for LDNS as well. You can program the provider using the configuration parameters that it needs. For Route 53, the AWS keys, access key and secret key, and the root domain. And Rancher will deploy the external DNS provider from the Kubernetes incubator project once you create this DNS provider entry. After this, you have to create the global DNS entry. So you add a DNS entry and specify the FQDN that you want to program. So you specify the FQDN that I just used on my multi-cluster app. And you choose the provider in order to program this FQDN. And either you resolve this DNS entry to a multi-cluster app, and I can select the demo app that I had just created, or you can select projects, individual projects under various clusters, and we will look for ingresses carrying this FQDN annotation in all these projects. So I'm selecting the multi-cluster app that I just created. You can specify a DNS TTL here of your choice. Global DNS also supports RBAC, so you can, the global DNS entry or the global DNS provider can be shared to different users so that the global DNS entry and provider can be managed by multiple users, and you don't end up just one single user account being able to manage them. Once I create this global DNS entry, the global DNS controller running in Rancher is going to look for ingresses of this multi-cluster app and pick up the ingress IP addresses. So here it has already picked up the IP addresses from the 2 target clusters of this multi-cluster app and programmed it on the global DNS entry, which is sitting at Rancher management layer. Now, the next step is the Rancher's global DNS provider that we had just created is going to pick this entry, which just got updated by the IP addresses, and it is going to program these 2 IP addresses on the Route 53 root domain that I have programmed. So shortly, we should be able to see an entry created on the Amazon's Route 53 root domain. I have already created one of the test apps, and for an existing multi-cluster app here. Until the programming happens, I can demo an existing external DNS being programmed for one of my multi-cluster apps. So this was picked up by the external DNS provider, and my multi-cluster app was using this test app prachitas.eng.rancherspace.fqdn, and it got programmed against the IP address of this cluster. So this is the workflow for global DNS and multi-cluster app. These two features I want to mention are actually independent of each other. So global DNS can be used to program any ingress by specifying the projects across various clusters that we should be looking for to program. And on the same side, on the vice versa, multi-cluster app is also independent, where if you don't want to use external DNS, global DNS of Rancher, you can not specify the annotation on the ingresses, and it won't be picked up by global DNS. So that's about it from the demo. Adrian?
Prachi, wow, that was amazing. These two features are incredibly powerful. I didn't even realize that global DNS works just directly with ingresses, that is not connected to multi-cluster apps. That blew my mind when you just showed that.
Yeah, that's right. So I just wanted to note that as well.
So we have a bunch of questions. Some of them are similar, but we have a lot of people who are asking about other providers besides Cloudflare and Route 53. We've got questions about Bind9, about Azure, about Active Directory, about using an internal DNS that supports RFC 2136. Do you know if any of those are in the roadmap? What's planned? Is there anything that you can tell us about that?
Yes. So what we are doing really is we are using the Kubernetes Incubator external DNS repo for launching the providers. So whatever this repo already has a bunch of providers, a big lineup already supported, and we will be able to support from Rancher all these providers. We will be able to enable them from Rancher UI and API. So we already have added support for Route 53, Cloudflare, and LDNS, and all of these like Azure, Core DNS, or DNS Simple, all of them can be enabled from Rancher with minimal effort. It is, and we are already working on making this, enabling all these providers from Rancher in a simpler way. So right now we can still do it. It will need a code change, but it is minimal. But in the roadmap, we are also thinking about being able to add these providers on the fly and make it easy to enable them.
Very cool. If somebody wanted support for a provider that's not in this list, they could theoretically clone this repo, write the Go programming for it, and submit it as a pull request to get it supported, right?
That's right, exactly. So they can put the provider of their choice in the upstream Kubernetes repo, and we should be pull that in and enable it in our UI.
It's fantastic. The power of open source. We have John who asked about IP addresses. This was early on in the presentation, and I think that you actually covered it later, but he just wants to make sure that the IPs are the ingress controllers, or the IPs of the ingresses and not of the services or the pods themselves, right?
They're the IP addresses of the ingresses.
Okay, cool.
That you have created to front your application. That's right.
So extending our conversation about what the IPs represent, I'm looking for this other question. Hold on. Dun, dun, dun. Aha. So we have Julian is asking if he's running a cluster behind a firewall with internal IPs and he wants to publish some arbitrary external IP that's like a NAT address on the outside of his router, is there a way to control what address global DNS publishes?
So right now, the global DNS is going to pick up the whatever IP addresses your ingresses are programmed with, ingress endpoints are showing. And if those ingresses use the FQDN annotation we need, we are going to pick them up and put it on the external DNS provider's ingress for programming the DNS. But I believe on the external DNS repo, there is a particular flag that we can provide to say that publish internal versus publish public IP addresses only. So, but as long as your ingresses of the applications running in the user clusters, if whatever IP addresses the ingresses are exposing, those are going to be picked up by our external DNS provider, which is sitting globally outside of your cluster.
Got it. Okay, so it sounds like then this if they have some external IP somewhere that's not known to the Kubernetes cluster, there's no way the Kubernetes cluster could know to go and publish that.
That's right. Your ingress is not publishing that. We won't be able to pick that up.
Yeah, that makes sense. Okay. Next question. We have some questions around features of DNS. Kaushik is asking if GlobalDNS has any ability to control rate limiting.
So the GlobalDNS provider that we are launching from the Kubernetes repo itself is trying to poll the external DNS APIs, and this polling interval is programmable, but I think by default it is 1 minute. We can extend it in order to make sure that we don't make a lot of API calls on the external DNS or the third-party DNS side. But other than that, I think rate limiting is not yet supported by the Kubernetes provider repo.
Okay. I have this like whole list of questions that some of which we answered because we hit all of those network provider questions. So I'm like picking back through them again. No, Power DNS, we answered that. Well, we'll come back to that one. Let's continue talking about DNS stuff. We have Amar is asking if, I'm not sure that, okay. So Amar is asking if 2.2 will support the existing kubeDNS, which is now present in 2.1. I'm not sure. Yeah. Do you have any thoughts about that?
I think kubeDNS is that is supported in 2.1 is the internal Rancher DNS. It's used for the internal DNS programming, and what we are supporting here is, I think, the DNS to be programmed on an external DNS provider.
So he may be referring to kubeDNS versus core DNS, but that's not connected to this global DNS in any way. That's just internal to Kubernetes.
The kubeDNS that we are supporting Rancher 2.1 is the internal DNS. And if we want to use that as an external DNS, it has to be first supported by the external DNS repo. I think core DNS is, I can see it is already there.
Yep.
But I don't see kubeDNS. Yeah. But the 2.1 DNS is internal, right?
Yeah, got it. Ooh, here's an excellent question from Peter. Peter wants to know if there are any GSLB features included in GlobalDNS.
So for load balancing, I think this is the global DNS feature that's coming in Rancher 2.2 supports external DNS programming. But with this, I think we have already laid the path, and going forward, we should be able to support global load balancing on top of this. So it's not in 2.2, but in future releases, I think we will be planning to support the LB at the global level too.
That's fantastic. Would that be just configuring GSLB parameters within the DNS providers themselves?
Or we will have to look at it, or it will be, I think, the other external LB providers like F5 can be programmed for your workload.
Understood. Okay. Awesome. Jesse is asking, what happens if an ingress controller fails? Will GlobalDNS automatically update, recognizing that one of the clusters is not responsive?
So if one of the ingresses is going down due to a cluster, that particular ingress IP address endpoint will be removed from the global DNS entry, and that will be ultimately removed from the external DNS record. So I think if I understand the question correctly, if the ingress in one cluster, if any cluster goes down, yes, we will update the IP addresses on the external DNS.
Is that a triggered event, or are we polling for that at some interval? Do you know how long it takes for that update to happen? Not propagation, but how long it takes for us to update?
Yeah, this is not a poll. So this is using the Kubernetes events. So it is a trigger. As long as the ingress gets deleted or its IP addresses change, that generates an event that we catch, that our controllers catch, and it's pretty fast that we will reflect it on the external DNS side.
If an application sitting behind an ingress started failing, let's say it was a web application that started throwing 500s, does that affect the ingress such that we would then pull it out, or would it stay?
I think if the application or the workload deployments are failing, we are not monitoring them. We are only monitoring the ingress state. So if the ingress is still active, but if it's the traffic is going and giving 500, that I think we won't be able to pick up the state of that.
Naveen asks, what happens if Cloud 53 or Cloudflare goes down?
Right. Yeah. If the external DNS itself goes down, yeah, I think that's a situation you don't want to be in.
No, that's a bad situation, but that's a situation that's outside of Rancher's control, right?
Correct. Yeah, it's an out of band event for us.
Still a good question. I've seen things happen on the internet that I thought I would never see. The internet was, it's big and powerful and can withstand everything, and then suddenly somebody just knocks out a big chunk of it. All right,
Yeah.
what else do we have? Um, we have Jose. I think you might have answered this. Jose is asking, how do we balance traffic across multiple clusters? But I think at this point we're just essentially round robin DNS,
That's
and
right.
that's
We
the
are on.
stand, right?
Yeah. Yeah.
Okay, cool. Just going through the last of them, seeing if there's anything that we missed. That's not a global DNS question. Okay, we have one question left, and this is actually about the multi-cluster apps. And we have Hank. Hank is asking about a situation where different clusters needed storage and some kind of maybe replication, or like is the multi-cluster app, does it have any ability to consider storage, or is it just really for stateless applications?
So I think the specific requirements of your app is up to the user. What multi-cluster app is providing is a way to deploy the application as long as all your configuration parameters or requirements are taken care of. The controllers are going to make sure that this application gets deployed to the targets and configured as you want onto these specific target projects. But storage requirements and all that, the brancher controllers are not going to go and ensure that your storage is in place. That is, I think, the user's responsibility to make
Yeah, that
sure
makes
that,
sense.
yeah, what we are
So,
providing is a deployment feature.
right. So in the edge computing use case that you described earlier, there's a restaurant chain who shall remain unnamed that has something like 3,000 different restaurants, each of which has their own little 3-node Kubernetes cluster that manages stuff within the restaurant. So this would be a really good use case for them where they actually need to push these apps out, but each cluster is autonomous and they don't need storage replicated between the 3,000 different environments. They just need to control the apps themselves. Even though the apps might be stateful, they're still stateful within each individual location. Is that accurate?
That's right, yeah.
Yeah. Okay. Makes sense. See if there's any last minute questions. DNS going to work with Istio. Oh, okay. I don't know if you have an answer for this, but it's an interesting question. Sarmad is asking if external DNS is going to work with Istio Ingress Gateway.
Oh, interesting. I don't have an answer for that right now, but I think that's a good thing to keep an eye on.
Yeah. Thanks, Sarmad. That's an excellent question. Istio is extremely popular. We have Istio working with some of the other projects that I alluded to earlier that you guys are going to be hearing about in the next couple of months. Obviously, Istio works great with Rancher and with any Kubernetes cluster that Rancher manages, but this is an interesting thing that we'll have to go and take a look at. I'll make a note of this for later.
Yeah. Thanks, Adrian.
Yeah. Oh, another last minute question from Philip. Okay, so this isn't actually a question, but this he says that the Microsoft Global Network of Name Servers has the scale and redundancy to give you ultra high availability for your domains. And with Azure DNS, you can be confident that your DNS will always be available. So I think that's a response to the earlier question of what happens if Route 53 goes down. I guess the answer is switch to Azure. All right. Just a last minute review. Answered that, answered that. Oh, Philip is continuing to promote Azure. Okay. All right, so that's it for the questions. This is one of those meetups that's not going to go long. So I will. Oh, Gabriel. Oh, now it's a fight between Azure and Route 53. Gabriel says that Route 53 has 100% SLA. So it sounds like you guys just need to do your due diligence on your DNS provider and make sure that whoever you choose will work for you. So in just a moment, I will take it back. We will wrap this up. You see my get started page?
Yep, we can see your page.
All right, fantastic. So if you guys are, well, guys and gals, if anybody here is interested in taking Rancher for a spin and seeing what Rancher can do for your Kubernetes cluster, for your multi-cluster, for multi-cluster apps, for any of the stuff that you saw today, and granted, if this is your first foray into Rancher, what you saw today were some really advanced specific features for specific use cases. But Rancher itself exists to make deploying, managing Kubernetes clusters anywhere in the world easy, fast, reliable, and with all of the tools that you need to get up and running with monitoring, logging, CI/CD integration, alerting, everything that you need. So even though today was an advanced meetup, props to you for sticking around, all of you. Thank you so much for that. And we encourage you to go and bring Rancher down. You can set it up in a development environment really, really fast. It just runs as a Docker container. If you want to deploy it in an HA environment, it runs within Kubernetes. We have instructions on how to deploy it both standalone and HA on our website. But it's 2 easy steps. You can get up and running, and you can start to take it for a spin. We have quick start guides. This is actually a snapshot of our documentation page. Our documentation is thorough, but we have quick start guides for getting started, or if you see there, the installation tab has the more in-depth installation about deploying stuff with your own certificates, Let's Encrypt, self-signed certs, HA, standalone, and everything else that you need to get up and running. All of our projects are open source. I know I said that at the beginning, but I'll say it again. Free to use, 100%, fully featured. We are an open source company. So Rancher, Rancher OS, RKE, they're all out in GitHub. Please bring them down. If you're a developer, contribute. If you're a user and you find anything that is either not working correctly or it could be doing better, open an issue. Even if you just have a feature request, a suggestion, all of those things go into GitHub issues, and that's how things get into the product. If there's something that you would like to see, go look for a GitHub issue that already recommends that, add your support to it. If it's not there, open an issue. That's how everything goes. So thank you all again for coming. We will have the recording up on our channel within the next day or two, and we will see you next month. Have a great day.